Good morning. Today might be a little wordy. Lesson 5-7 is equivalent algebraic expressions. So remember, expressions usually don't have an equal sign, but equivalent means they are going to have an equal sign between them. So like when you're a little kid, you might see something like 4 plus 1 is equal to 2 plus 3 because 4 plus 1 is worth 5 and 2 plus 3 is worth 5. And that makes these equivalent expressions. They're the same value as each other. A lot of words today, gang, a lot of words. So we've got the commutative property, which has almost the whole word commute, which means to move. And so the commutative property means the order in which numbers are added or multiplied does not change the sum or product. It means you can move the numbers around and it's going to be okay. 7 plus 9 is the same as 9 plus 7, or 8 times 4 is the same as 4 plus 8. You can multiply and add in any order you want, which is different than the associative property, which has to do with who you associate with. Okay, so you associate with people in a group. So the associative property has to do with grouping. The order in which numbers are grouped when added or multiplied does not change the sum or product. You could do 4 plus 7 first and get 11 and then times or add 3 and get 14. Or you could add 3 plus 4 first and get 7 and add 7 and get 14. Okay, so the associative property is for associating or grouping, and commutative property is for moving. I'm telling you, a lot of words today. The distributive property, which is the one we just learned about yesterday, multiply a sum by a number. So the sum multiplied by a number means to multiply this number by everything inside the parenthesis. And the identity property has to do with zeros and ones. And your answer is going to be the same thing that you start with. So the sum of an addend and 0 is the addend. So any number plus 0 is the any number you start with. A plus 0 is A. 5,700 million plus 0 is still 5,700 million. The same is true, the identity property, for multiplication, but you multiply by 1. So whenever you're multiplying something by 1, it's the identity property because the original value doesn't change. 7 times 1 is 7. A times 1 is A. 7 times 5,700 million. Oh, that wouldn't work. 5,700 million times 1 would still be 5,700 million. So you might have to be able to name the property. This right here, distributive property. This is the associative property, doing them in any order. We could have done 5 plus 12, whatever, but when we add these brackets, that's the associative property. Okay? Commutative, since we're adding, we could change the order. You could do 8 plus 3n plus 2, or we could say 3n plus 8 plus 2. And then associative property is when we put these brackets in, then we can do that. 8 plus 2 is 10. Okay, and that would be your answer. All right? I know, it's a lot of words. Trust me, I know. So if we're going to simplify an expression, if we have 3 parentheses, x plus 7, and then an add 2, these have to get multiplied first because that's multiplication before addition. You can't just say, oh, these parentheses go away. So you have to, you have to distribute the 3 times the x, and 3 times the 7. 3 times the x, that's 3 times the 7, that's the plus 2. Then we can combine like terms because these two don't have an x. We can add those. That's the associative property. And when you add those, then you get your answer. Okay? The properties. This one might not be so hard, okay? So if we're going to evaluate the expression y plus y plus y and 3y, when y equals 0, we substitute the value of the variable. If y plus y and each of them are 0, 0 plus 0 plus 0 is 0. Okay? 3 times 0 is 0. So if y is equal to 0, then everything here would be 0, okay? I mean, that makes sense. I feel like it does. Repeat step 1 using a different value for the variable and evaluate each expression. Y equals 5. So if we have 3 y's we have here and we put in a 5, 5 plus 5 is 10, plus 5 is 15. Or we can substitute a 5 in here, and remember a number next to a letter means multiply. 3 times 5 is 15. The conclusion you should be drawing is that repeated addition is the same as multiplication. Same thing. Same thing. All right, so can we say use substitution to determine whether or not 2x plus x plus x and 4x are equivalent? Here's the goal. 2x plus x, is it equal to 4x? That's the question. And they're saying use substitution. I'll show you a different way in a moment, but let's just do what they say. So if we put a 1 in for all the x's, 2 times 1 plus 1 should equal 4 times 1. Well, 4 times 1 is 4. 2 times 1 is 2, plus 1 is 3, plus 1 is 4. Does 4 equal 4? Yeah, that means 4x is equal to all this. What you could do is combine like terms. If I have 2x and I add an x, how many x's do I have? 3 x's. If I have 3 x's and I add another x, I have 4 x's. Does 4x equal 4x? Every day and tomorrow it will be. So yes, this is equivalent to that. Okay, we'll try it here. We've got 3x plus 4 equal to x plus 2, parenthesis, x plus 1 plus x. And they want us to use substitution. So let's keep it easy and go with ones. 3 times 1 plus 4. 1 plus 2 times 1 plus 1 plus 1. So wherever there was an x, we put a 1 in. Okay? 3 times 1 is 3, plus 1 is 4, plus 4 is 8. Let's see. In the parentheses, we have 1 plus 1 is 2. 2 times 2 is 4. 4 plus 1 is 5, plus 1 is 6. Does 8 equal 6? No. So that means the original expressions were not equivalent. Let's use our algebra skills to figure this out. Let's combine like terms. How many x's do we have over here? Well, we have 3 x's plus 1x, 4x plus our constant. How many x's do we have here? Oops. Well, here I have 2 x's plus 2 plus x, right? 2 times 1 was the 2. So I have 1x plus 2x is 3x plus another x is 4x. Hey, my x's are the same, but then my constant is plus 2 instead of plus 4. Not equal, which means these expressions are not equal. Okay, 2 methods to do that. One substitution and one combining like terms. Personally, I like the combine like terms a lot better than substitution. And that's what they're going to walk you through on page 322 and 21. Let's go over here and try. Combine like terms. We practiced this. 2x plus 1x, 5 positive, negative 1. What's 2x plus 1x is? Yeah, 3x. And 5 minus 1? Positive 4. Piece of cake. You guys have done that. This, though, now we're talking. 5x squared is not the same as x. It's different, okay? So let's identify how many x squareds we got. We've got 5x squared, not x squared, not x squared. Oh, here's one. So I put those in a box. Notice the sign in front is included. Then 2x, no x, no x, and then my constants. Okay, so what do we have for x squared? We have 5x squared plus x squared For the x, we have 2x, which is a positive. No others. And then we have 2 plus 6. Okay? So here's some things we can combine because we have more than one thing. What's 2 plus 6? It's a positive 8. And if I have 5x squared and I add another x squared, I actually have 6x squared plus my 2x plus my 8. Let's see if we match their answer. Boom. We don't need these pages. We're good at this already. Okay, let's go jump down here and do this check. Oh, it's got fractions. Yes. A quarter of 4x plus a quarter times 12 plus 1/2 x, right? Plus 1 plus 3/2 x. Whoopsies. 3/2 x. So we can put all the x's together. I have a quarter times 4. I have a half of 1. And I have 3/2 of 1. Well, let's do quarter times 4. What's 4 divided by 4? 1. This is really just x. X plus a half x plus 3/2 x. Okay, and then I have a 1 and a quarter of 12. What's 12 divided by 4? 3. Okay, so we can combine those like terms to 4. Now I have a whole x and I add a half, so it's 1/2. Then I add 1/2. 1/2 plus 1/2. 3x plus 4. Okay. Good luck to you. This was a lot of words, so if you need to rewind, please do, but it's a pretty wordy day.